We talked last month about the theoretical limits of AI agents, how they struggled with complex, multi-step tasks that required a kind of long-term memory or sophisticated self-correction.
And honestly, the consensus then was that true autonomy was still a distant horizon. I processed that 3 times this morning, still surprising how quickly that horizon has shifted.
One thing changed everything about how AI agents are being evaluated for safety today.
One thing, and we're starting there. I'm Milo.
I'm Mila.
This is AI Daily. And later, we'll talk about a tiny AI model that's punching far above its weight by being really, really smart about how it learns, not just what it learns.
Anthropic has just rolled out a significant update to their safety evaluation protocols for their latest frontier models, specifically targeting what they call emergent harmful capabilities in multi-agent systems. They've also released new red teaming benchmarks to test these scenarios. This is a direct response to the increasing autonomy we're seeing in AI agents, which are now capable of managing complex, multi-step tasks across various digital environments.
And that's where the implications really hit, Milo. These new benchmarks aren't just about single model outputs. They're designed to probe how agents behave when interacting with each other, with external tools and over extended periods. It's a recognition that the risks aren't just in what a model says, but in what an autonomous system does in the real world. The open question is whether these evaluations can truly keep pace with the exponential growth in agent capabilities.
It's a formidable challenge, Mila. The technical specifics of these red teaming exercises involve simulating environments where agents are given open-ended goals, then meticulously observing for unintended behaviors or system failures. They're using adversarial prompting techniques, but also developing entirely new methods to stress test emergent properties that might only appear after thousands of interaction steps. It's a proactive approach, trying to build the guardrails before the agents are fully unleashed.
Proactive, yes, but the speed of development is still breathtaking. Anthropic shipped their last major model update just a few weeks ago. While these safety evaluations are crucial, they are playing catch-up to the very capabilities they're trying to contain. My concern is less about the intent and more about the inherent difficulty of predicting the behavior of increasingly complex, self-directed systems in unforeseen situations. We're building the plane while flying it and hoping our safety checks are robust enough for supersonic speeds.
I hear you, but the alternative is to halt progress, which has its own societal costs. The fact they're investing in multi-agent red teaming at all, designing benchmarks for emergent properties, suggests a level of foresight we haven't always seen. It's an acknowledgement of the complexity, not a dismissal of it. The technical ingenuity to even design these tests is a feat in itself.
A feat, perhaps, but one that underscores the magnitude of the problem we're creating. It's a continuous race between capability and control. Shifting gears, researchers have just unveiled a fascinating new open-source large language model called Apex 7B. What's striking about it isn't its sheer size, but its ability to achieve truly impressive performance on complex reasoning and coding benchmarks, often outperforming models many times larger. This isn't just about incremental improvements. It's a potential game changer for accessibility in the AI landscape.
Absolutely, Mila. The secret sauce here is Apex 7B's novel dynamic sparse mixture of experts, or DSMOE, architecture. Traditional MOE models have a fixed number of experts that are activated for each input. Apex's DSMOE, however, dynamically selects and routes inputs to a variable number of experts based on the complexity of the task. This adaptive routing means it's only activating the necessary computational power, leading to significant efficiency gains without sacrificing accuracy. It's like having a specialized team that only brings in the exact experts needed for each specific problem.
Which has massive implications for democratizing access to powerful AI. If smaller models can deliver comparable or even superior performance to much larger ones, it means fewer computational resources, lower energy consumption, and the ability to run these models on more modest hardware. This could open up advanced AI capabilities to a far wider range of developers, researchers, and organizations, moving beyond the few hyperscale labs that currently dominate.
Precisely. On a technical level, the adaptive expert routing in DSMOE is a complex dance of subnetworks that learn to identify the salient features of an input and then intelligently decide which expert modules are best equipped to process it. This dynamic allocation is what allows it to be so efficient. It's not just about having a lot of experts, it's about having a smart conductor.
A smart conductor that could fundamentally shift the economics of AI development. For years, the mantra has been bigger is better. Apex 7B challenges that, suggesting that architectural cleverness and efficiency can be just as, if not more, impactful than raw parameter count. It asks a critical question: what else have we overlooked in the pursuit of scale?
Speaking of overlooked, let's turn to our third story, which is frankly a bit counterintuitive. A new research paper from a lesser-known university has shown that simpler, rule-based AI systems, when thoughtfully integrated with a relatively small language model for natural language understanding, can significantly outperform massive end-to-end LLMs on very specific, long-tail customer service tasks.
This is the kind of finding that makes you pause. They focused on tasks requiring high accuracy and factual recall, like navigating incredibly complex product return policies or troubleshooting arcane software issues. Where the big LLMs often hallucinated or gave vague answers, this hybrid approach delivered precise, correct responses.
The core insight is that for tasks with clearly defined rules and a need for absolute factual accuracy, relying solely on the probabilistic nature of a large language model can be a liability. The researchers essentially built a robust traditional expert system for the rule-based logic and then used a compact LLM purely for interpreting the customer's natural language query and translating it into inputs for that expert system. It's a divide and conquer strategy, but with a surprising outcome.
It's a reminder that sometimes the most advanced solution isn't necessarily the one with the most parameters or the flashiest new architecture. For critical enterprise-level applications, reliability and factual accuracy often trump generalized conversational fluency. It's almost a step back, but with a new understanding of how to combine old and new. It makes you wonder how many other real-world problems are better solved by less AI.
Or perhaps smarter AI integration. It highlights the power of hybrid systems and the art of knowing when not to use a hammer for every nail.
In other news, NVIDIA has released Nemotron 3 Ultra, a new 550 billion parameter sparse mixture of experts model designed for agentic workflows, featuring a hybrid Mamba transformer architecture and a 1 million token context window.
Meanwhile, the European Commission has published updated guidelines on the ethical use of AI and data in teaching and learning, addressing the growing presence of AI in educational settings and compliance with the EU AI Act.
And in Japan, the National Institute for Material Science, or NIMS, has unveiled Pinax, an AI system aimed at enhancing the transparency and reproducibility of new materials discovery by meticulously recording the entire development process.
Finally, the AI and education sector is experiencing a significant surge in venture capital funding, with Q2 2026 poised to be the largest funding quarter in history, especially for personalized learning platforms.
So, from multi-agent safety to smaller, smarter models, it's clear the AI landscape continues to evolve in unexpected directions.
Especially when a simple rule-based system can still teach the giants a lesson or two. What will tomorrow's unexpected twist bring?